Hello and welcome to this video on residential load calculation. This will be applicable for the NFPA 70 National Electrical Codebook 2017 version, 2020 version, and will mostly cover everything in the 2023 version, although the 2023 version of the residential load calculation does have a little bit more in it. Okay, so first off, we need to go into Article 220 of our codebook. I'm going to be using the 2020 edition codebook. And this article of the codebook is called Branch Circuit Feeder and Service Load Calculations, Article 220. That's why I put ART for Article 220 if you're not familiar. So right off the bat, we want to go on the first page and we see 220.5 calculations. We see A voltages and B fractions of an ampere. These are both important. The voltages is something that you should be familiar with. It is that we are going to be using nominal system voltages, and you see the different voltages listed. This can be 120, 120/240, 208Y/120, 240, 347, 480Y/277, 480, 600Y/347, and 600 volts are able to be used. And of course, they use the terminology shall be used, which is basically saying you have to use these. It's different terminology than when sometimes they say permissible. This is permissible. That means you're allowed to do it, but it doesn't mean you have to do it. Okay, so then we're going to go from section A there that we just read to section B. We see fractions of an ampere. Basically, to sum this up, you're going to get a number at the end of your load calculations, and the ending number that you end with might have a decimal. If it has a 0.5 or above, you're going to round that up, just like you normally would in math. And then if it is 0.49 or below, you're going to round down, which means you're going to keep the number the same thing. So let's do a short example of that. So let's say you have the number 27.6. That's your ending number. Okay, so you're of course going to round up because you end on something that's above a 0.5. So now our ending number would be 28. Of course, I'm talking ending number because you're not going to do this the entire time every time you get a number that has a decimal, or else you're going to actually get an incorrect answer. You're only going to do this, like I'm saying, when you have your ending number and you say, okay, this is my answer. Okay, this is the final answer. Then you look at that and you say, okay, this is above 0.5, we're rounding up. Let's say in the other circumstance, we had a 20.3. Okay, 20.3, obviously, that's under 0.5 there, so we're going to round down. But rounding down is kind of funny terminology because all that means is we're going to keep the number the same. We're not going to change the number and round up. Of course, we're getting rid of the decimal, so that's why you would technically call it rounding down. And just simply think, if you have a decimal point of 0.5 or above as your final answer, your final ending number, then you're going to round that up. So you're going to raise it 1. And if your decimal point is 0.49 or less, in other words, less than 0.5, then you're going to round down, which you're just going to get rid of that decimal. Okay, so now you can see the style of this video. We're going to be reading from the codebook the rules. So not only can we trust these rules because we're actually just reading them from the codebook, but now we know where to find them. So I think the most important thing about the codebook is to not have everything memorized. That's why you have the codebook. It's to remember where to find everything. So you just think, okay, I want to find the rules for my load calculations. And if you highlight things, which you're able to do, you are not able to actually add notes if you're going to bring your codebook to a test, but you're able to highlight and underline things, okay? And with that, you can open up your codebook and you know where the load calculations are. You can also get your tabs online, your codebook tabs. So make sure you have all that if you don't. But the point of what I'm saying is you're going to know where to find this stuff. And sometimes you're not going to remember the exact number, or you might second guess yourself, which is perfectly fine. Okay, and now you can go back here and you know where everything is. And that's going to be the style of this video, okay? So the rules that I'm going to be teaching you from the codebook. Okay, first off, we're going to be calculating what is called the general lighting and receptacle loads. This is going to cover all of the general lighting in the house and all of the general receptacles. This applies to bedrooms, living rooms, and also hallways. We typically know these as the 15 amp outlets throughout the house, although this might differ depending on if the homeowner or the builder wants 20 amp receptacles throughout the house and or a 20 amp lighting circuit. They might want this and they might ask for this. You don't need to actually know this information about if it's 15 amp or 20 amp receptacles, or if they're going to be using 12 gauge, in other words, for their lighting circuit, or what is called the general lighting receptacle load. It's just good to know that people might ask for something different, and just to kind of figure out what we're talking about here, generally it's those 15 amp outlets throughout the house and that lighting circuit. That is all those 15 amp breakers that you see on most people's panels. Okay, and since we're doing residential, this is going to apply to single family, duplex, which is also two family, or multi-family, which means 3 or more. We can see what looks like maybe an apartment building and it has 12 units. Okay, so what we're going to want to know for our general lighting and receptacle load is that we're using the calculation of 3 volt amps per square foot. So we might see square foot written out a few different ways. We might see it written out actually spelt out, square foot. We might see that abbreviated as SQFT, which is the square foot. And we might simply see feet squared, square feet. Okay, so just be familiar with those different variations. And what we're going to do is we're going to get the square feet of the house that we have, and we're just going to times that by 3. And of course, it's going to be 3 volt amps, which brings us into the fact that here in these load calculations, when we're talking about volt amps and when we're talking about watts, we're actually going to be using these interchangeably, even though oftentimes you're going to be using volt amps in a circumstance when you don't actually know your power factor, and you're using watts when you do know your power factor. But like I'm saying, here in these load calculations, we're using these interchangeably. So they might say you have a garbage disposal at a certain amount of watts, and then you have a refrigerator at a certain amount of volt amps. And if you're adding those together, you're going to be treating those the same. So the volt amps and the watts are just going to be added together. Okay, and to keep with the theme of the video, I'm going to tell you where to find this in the code book. But also, this is not in order here. This jumps quite further, the 3 volt amps, but I think it's good to mention it right now. Okay, so if you want to find that in the code book, you go to article 220.82 dwelling unit, and then you go to B general loads, and you'll see under 1, it talks about the 3 volt amps per square foot for general lighting and general use receptacles. Okay, and then it furthermore gets into the next part of what I'm talking about here. The floor area for each floor shall be calculated from the outside dimensions of the dwelling unit. Okay, and if we do go back in the very beginning, like if we're looking at this article in order, if we go to the second page, we see where it says Part 2 Branch Circuit Load Calculations. We see Article 220.11 floor area, and it talks about the same thing, that each floor, the area of it is going to be calculated on the outside dimensions of the dwelling unit. Okay, and they like to trick you, so who knows, they might ask you a question about load calculation, and let's say they have a picture, and they show you certain inches going one direction, inches going another direction, okay, and then let's say there's a number actually in the middle of that, okay, and it shows you the area of the inside dimensions, and then somewhere kind of hidden in the question or vaguely in the question, it mentions the square inches of the house, because you're supposed to know that's based on the outside dimensions. I don't know if they'd actually do that, but just really know that you're working with your outside dimensions. Okay, and this is based on the actual dwelling here. Let's say we add a garage. Okay, so we have a garage, and then, you know, we might have an actual outside porch. Okay, and the thing about this outside porch is that this is a space that is not going to be considered adaptable for future living space use. It's just an outside open porch, and that's oftentimes how it will be worded, is it will be worded as an open porch. And other basic non-living spaces, such as things like your garage and an open porch. Okay, well, these will actually not be counted as part of our lighting load. Okay, so we're going to disregard any time that we have a certain amount of square feet garage or an outside open porch. But if they mention that, let's say that it is adaptable for future use, then you will count that. Okay, so that's where they're going to get you. So make sure you pay attention to that, and they will have to mention if it is adaptable for future use. Okay, and there will be questions testing you on this, so don't worry about that. Okay, so here we are with the first question. Make sure you have a piece of paper or something to write this down on, as you're not going to remember this if you just watch this video, but you will if you write this down. Okay, so we're looking at a 1,500 square foot dwelling that has a 500 square foot attached garage and a 500 square foot basement that is adaptable for future use. Okay, so the attached garage we're not going to be counting, but we see the basement is adaptable for future use. So we're going to get the 1,500 square feet of the actual dwelling, and we're going to add 500 for that basement that is adaptable for future use. That, of course, is going to give us 2,000 square feet. From here, we're simply going to get the 2,000 square feet, and we're going to times that by our 3 volt amps, and that is going to give us 6,000 volt amps. Okay, now we're just going to stop here for now because this is going to teach us what we need to know for this lesson. But just know that there is more to this general lighting and receptacle load, but we will get into that later. For now, we're just going to look at this simply as this is, and we're going to think of this as with no demand factor. Okay, so we don't have a demand factor yet. We're just thinking about getting this number. How do we get this number? Okay. And it's by getting the 1,500 square foot of the house, disregarding the attached garage, and then also counting the basement and getting that total number and multiplying it by 3 volt amps. Okay, this is very important, so just remember that this is not a final answer, but this is important how we get this number. Okay, next question, we have a 2,800 square foot home, a 500 square foot bonus room upstairs, and a 500 square foot open porch. Okay, so obviously we're going to count that 2,800 square feet from the actual home itself. But what's this business about the 500 square foot bonus room upstairs? It's kind of odd, okay? They will say things like this to throw you off. In fact, a bonus room upstairs is just going to be a part of this general lighting load. Okay, so we are going to add the 500 square feet from the bonus room, but we know that we have additionally a 500 square foot open porch, and we're not going to count this 500 square foot open porch. We get 2,800 plus 500, and we're going to get 3,300. Then we're just going to get our 3,300, which is the total number of square feet that we're working with here. And then we're going to times that by the 3 volt amps, which is going to give us 9,900 volt amps. And again, this is the number that we're looking for, but this is not going to be a final number for a general lighting load. Okay, so for this next part of this lesson, we are going into part 3 of Article 220, and we are going to be looking at Article 220.52. This is small appliance and laundry loads in dwelling units. Okay, so we want to read this carefully in the code book, and we want to know that this is going to be the very minimum. So if they don't tell us anything about the house, and they just tell us, let's say, the square feet, we're every single time going to include these base calculations. And this is that we have 2 small appliance branch circuits. Okay, know that this means small appliance branch circuit. And know that your small appliance branch circuit basically just means the circuit that's going to be in your kitchen. You need 2 kitchen circuits for your small appliances. It's a branch circuit. That means it's just a circuit coming from your panel. These are going to be rated at 1,500 volt amps each. Okay, and there's going to be 2 of them. So you put that together, you have 3,000. When you think of small appliances, think of appliances that are not going to be fixed, okay? They're not fastened in place like you can have a microwave that you just get from the store and plug in and put on your counter. As you might know, you might also have a microwave dedicated circuit. That's different, okay? We're talking about small appliances that you can just move around your kitchen. Toaster ovens, blenders, stuff like this that you just set on your counter, and they are small appliances. Oftentimes with motors, or draw a pretty good amount of load compared to something like a light bulb. Okay, but then we also have one laundry circuit, okay? And that is going to be the minimum 1500 volt amps every single time for that one laundry. Okay, and we see this is the minimum. It's 2 small appliance branch circuits. But the fact is that each of the small appliance branch circuits have to be rated at 1500 volt amps each. So if there's, for some reason, which oftentimes there will be, a third small appliance branch circuit, well, that's still going to be rated at 1500 volt amps, and every single one of these small appliance branch circuits rated at 1500 volt amps each will be added to the residential general lighting load. Okay, so this is all getting added to the number that we found before that we worked out from just our square feet. Okay, that might be known as our square feet volt amps. Okay, the square feet times 3 volt amps, that answer, we're going to be adding this to it. And we also see that we have the minimum of 1 laundry, and it's just really good to know that it's the same thing, that each laundry branch circuit is going to be rated at the 1500 volt amps. So if there happens to be more than 2 in a dwelling unit, it's going to be 1500 volt amps each. You can find this in the codebook at 220.52a and b. Basically, to sum this all up, we have 3000 volt amps from the 2 small appliance branch circuits, which we know is basically just our kitchen circuits for things like blenders and stuff like that. We're going to add our 1500 square feet for our laundry circuit, and we're going to come out with 4500 volt amps that is going to be added every single time to that lighting load. Okay, so they tell us we have a certain amount of square feet in a house. We're going to find out the number that we're working with, our square feet, times it by 3, get that number, and then we're going to add this 4500 number to it every single time. And this is even if they don't mention that they have any small appliance branch circuits or laundry. This is the code. You have to have this. Okay, so you have to have 4500. Like I said, they might get tricky and throw in some extra stuff here. Know that each one of your small appliance branch circuits will be rated at 1500 volt amps each. You need a minimum of 2, and your laundry will also be rated at 1500 volt amps, and there will only be 1 of those at minimum. And the reason why I'm going over this so much is because I never see anyone talk about the fact that this is the minimum, and that there might in fact be some more numbers that you're working with here besides the very minimum. Okay, so when you're doing load calculations for a whole house and you're doing a dwelling unit, you're going to get the square feet of the house. So let's say you have a 2000 square foot home. You're first going to find what could be called your square foot volt amps. And this is simply getting the square feet of your house, 2000 square feet, multiplying it by that 3 volt amp per square foot, and then getting 6000 square foot volt amps. Okay, and of course it's just a rating of volt amps, but it's based on the square footage of the house. So now that we have this number, we're always going to add that 4500 to this, which of course comes from the 2 small appliance branch circuits, along with the 1 laundry circuit, giving us that 4500 number. So of course we add that all together. We're going to get 10,500, and that's the actual number that we're going to be working with for our general lighting load. Okay, so it always includes the 2 small appliance branch circuits and the 1 laundry, when we simply see all that we had here was a 2000 square foot home, and we want to know how many volt amps are we going to be working with this home. They didn't mention anything about a laundry, they didn't mention anything about kitchen or small appliance circuits, but we still know that we had to add our minimum of each, getting us 45,000 and getting us our 10,500 number. Okay, and then we're not done when we find that number here. Additionally, then we're going to have to apply a demand factor. But to not complicate this too much, we're going to stop right here, and just like before, we're going to add in the other information when it seems like a good time. It'll all make sense. And just like before, you saw how finding that first number was crucial. We still need to find that first number. All we did was added another number to this. Okay, so we have this number. Just know we're going to apply a demand factor. This might seem complex at first, but just realize with some time, you're going to look back on this and say, it's actually not all that much. It's just the first time you look at it, and there's all these new codes and all these new rules. It does seem kind of like a lot. I remember when I first looked at it, but I've been doing this for quite a while now. And now when I look at it, it's just completely simple. And it actually seems really easy now. Okay, now we're going to be looking at fixed appliances in whole house load calculation. For this, we're going to be looking right after where we just were in the codebook, which is going to be Article 220.53, appliance load for dwelling units. Okay, so this is going to apply for dishwashers, garbage disposals, water heaters, central vacuum systems, built-in microwaves, or any fixed appliance. In other words, an appliance that actually is fixed in place. It has screws, or it's held in place by fasteners, like if you had a microwave with a dedicated microwave circuit. Okay, so now let's look in the codebook of the definition of what fixed equipment actually is. We're going to flip ahead to Article 250.110, where it says equipment fastened in place. You see it says fixed or connected by permanent wiring methods. Okay, and we see that pretty much sums up the definition of what we're working with here. When we're thinking of fixed appliances, we're thinking of equipment that is fastened and placed, that means fixed, or it is connected by permanent wiring methods. So there might just be a home run to a microwave, it's a dedicated microwave, it might not be fastened in place, but you see that would be an example of an appliance that you would consider in the fixed category, which in that case would just be connected by permanent wiring methods. Okay, so now we know what we're working with here when we see the appliance load. Okay, and when we think of our fixed appliances, the two exceptions that we're not going to be counting in this actual fixed appliance calculation is going to be our ranges and dryers. And this is because our ranges and dryers are going to be calculated completely separately with their own set of rules. And I'm going to teach you a method when we get into the whole house that is going to give you a sort of saying to memorize everything you need to know to figure this out. And this will all fall in place, it'll all make sense, and it will not be confusing if you follow all these steps and watch the video all the way through. However, if you skip the video and go all the way to the end to the whole house load calculation, good luck to you, because if you don't remember everything I taught, then you're probably not going to know where to find everything in the codebook like I'm teaching throughout this video. So just take your time on this, watch this video one time, maybe when you're eating food even, and just get an idea of what I'm talking about, okay? And then the next time, sit down with your codebook and a notepad and actually watch this video. I really recommend this method. It'll be like everything I'm saying. You already heard me say it, but now you're going to actually sit down, really pay attention to it, and it's like I'm just saying it a second time, but now you're actually sitting and connecting the dots. I find that to be a lot better than going in all at once and just trying to watch the video. Okay, and really take your time with this. I know this is one video explaining all this stuff, but this is not expected for you to watch this one video one day and figure out all this, okay? It might make more sense actually to watch certain sections of this video one day at a time. Maybe even one day at a time with a break in between to think about what you actually heard and solidify it in that category so you don't learn all this stuff all at once and you kind of forget where exactly everything fits. You know all these numbers, you know all these rules, but you kind of don't know exactly where they fit. And that's why I also recommend taking your time. Okay, really knowing fixed appliances and knowing how to do that. And then knowing all the other separate things. Okay, so that's why this will all be separated. You'll see timestamps in the video and you'll be able to find each separate lesson. If you're confused at any point, feel free to leave a comment in the comments below. Okay, because this is one of the most intimidating topics, the whole house load calculation. But in fact, compared to all the other stuff that you need to know for even your journeyman test and stuff, this really is not that big of a deal, and it ties into basically everything you already know with some very simple multiplication and addition, and you just got to know when to do stuff, and the codebook tells you what to do, when to do it, how to do it, okay? So it is very straightforward with this, and it does seem intimidating, but this is very simple once you actually understand it. It's just something you have to tackle, something you have to spend time on. Okay, so when we're talking about our fixed appliances and whole house load calculation, we have a demand factor. Again, our demand factor is if we have 4 or more fixed appliances, we're going to multiply that by 75%. And really understand it's 4 or more. So if you do only have 4, you're still going to do a 75% demand factor. This demand factor will be calculated on the nameplate rating of your fixed appliances, which is just going to be your volt amps that they tell you. Okay, or they might get tricky with the fixed appliances and tell you that you have something containing a motor or just a motor. And they might tell you that, let's say you have a certain horsepower and a certain voltage. Okay? And they might just tell you that. That's it. Then from that, you're going to have to know that if they don't tell you anything, it's going to be a single phase motor. You're going to have to go to table 430.248 for your full load current in amps for single phase alternating current motors. You're going to have to know it's alternating current, it's single phase, all that just from them telling you that. If they tell you it's 3-phase, then you go to the 3-phase table. Okay, but let's just say that they told you that you have a 1/4 horsepower motor at 115 volts. Okay, then you're going to go into the table, you're going to see 13.8, and then you're going to multiply 13.8 by 120. You're going to get your volt amps, and that will be the number that you're using. I've seen this before, so just know that that might be a possibility. They're going to tell you you have a motor of some sort, and oftentimes they won't tell you anything past that it's single phase or anything, so you're just going to have to know if they don't tell you it's single phase. We also see here in the NEC 2020 that it mentions that if it's rated a 1/4 horsepower or greater, 500 watts or greater, then we're going to count it as one of these appliances in this appliance load. But if it's less than a 1/4 horsepower or less than 500 watts, we're not going to be counting. Okay, and that's something some people don't mention. So I'm not quite sure if they have that in 2023, because it's in gray here in 2020. So that means it's a new addition to this version of the codebook. Okay, so just something good to mention. Okay, so I'm going to go into an actual question on this. This is very simple. But something else that I don't see people mention is that if we go back to Article 220.12, we also see that it mentions motors rated less than 1/8 horsepower and connected to a lighting circuit shall be considered the general lighting load. Okay, so I've never seen someone mention that. I've never seen that on any sort of thing that's asking for a load calculation. So I'm not sure if they would throw that in there or anything, but just know that is in the codebook. Okay, and probably just highlight it. So maybe something weird pops up on the test to where they say, oh, we have this less than 1/8 horsepower motor connected to the lighting circuit, then you're going to know what to do. Okay, so we see that's kind of odd, but I've never seen anyone mention that. So it probably is something that's in the codebook that they don't actually test on. But again, I want to kind of mention everything in these videos. So just in case that does pop up, you're going to know what to do. Okay, so if you aren't familiar with demand factors are a percentage or a multiplier. It's something that's going to increase or decrease the number, such as taking 80% of something and getting a decrease, or getting 125% of something and getting an increase. Okay, so I'm going to tell you what we're working with, and then I'm going to show you how I would write this down on a test to make this a little easier and to organize this. Okay, so first I'm going to read off what we're working with. We have a disposal at 900 watts. We have a water heater at 3,500 watts. We have a central vacuum system at 1,200 watts and a microwave at 1,200 watts. Okay, and if they're mentioning that we have a microwave, this doesn't mean that someone bought a microwave from a store and plugged it into the wall and set it on the countertop. This is a fixed appliance, so that's why they're mentioning this to us. Okay, so I like to write everything as follows. So I like to first look at what I'm working with, and I personally write everything in caps for my appliances. I'm not really sure why, but I've always done it this way. I think a lot of it is that I abbreviate things. So if I have a garbage disposal, I'm going to write dispo. This is oftentimes how you're going to see breakers in a panel labeled as well. If I have a water heater, I'm not going to want to write out water heater. I'll write WTR for water, and I'll write HTR for heater. Okay? Like you're texting back in 2000 whatever with one of those flip phones, okay? Next we have central vacuum. So again, we're just going to be taking out the vowels here. Central vacuum. We're going to give ourselves basically just enough to know what we're working with here. If some other abbreviation works better for you, of course, you're going to be using that. And then next we have the microwave. So of course, we're just going to call this a micro. A very common abbreviation, like how commonly you'll call a refrigerator a reefer. You might just write a line on the test, but that might not look very pretty for the video. So I'm actually just going to do some colons here. Okay. And the numbers that we're going to be working with, I'll line those up. Okay, so we see that we're working with a disposal that was the 900 watts. Okay, and make sure that you're labeling each one, even if you're pretty confident. If it says volt amps, if it says watts, you're writing that down. Because if it says amps, or if it says voltage in amps, horsepower, you're going to write that down as well. You're going to know what to do. Okay, so next, we're going to line everything up. We have 3,500 volt amps or watts for the water heater. I did originally say watts, but just know it could be either one. And then we have the central vacuuming system that is going to be the 1,200 watts, and the micro, which is also going to be 1,200 watts. Okay, those are all of the numbers we're working with. We can see they're all already in volt amps and watts, the number that we're going to be working with here, because we're always working with volt amps in load calculation. Okay, now we're going to simply add everything together. We're going to get 900 plus 3,500 plus 1,200 plus another 1,200. Okay, and we get the answer 6,800. But is this the final answer? Okay, and you should quickly know that no, this is not the final answer. Okay, actually I won't box it yet. And why is this not the final answer? Okay, look at how many of these appliances that we have. We have 4 appliances. If we have 4 or more appliances, we have to do the 75% demand factor. So in this case, we do have 4. We're going to multiply this by 75%, or as a decimal, we're going to multiply 0.75. 6,800 times 0.75 is going to give us a final answer of 5,100 volt amps or watts. Okay, so now why do we do this demand factor of 75% for 4 or more appliances? And that is because we're assuming that the inhabitants of the house are not going to be using all 4 of these appliances all at the same time. So that we see our final answer for our appliances in this load calculation. Of course, this would just be a certain section of a whole house load calculation, and this would be the fixed appliance section. Okay, so now you know how to do that. We'll call this number 1, and now we're going to get into number 2. Number 2, we have a water heater that is 4,200 volt amps. We have a garbage disposal at 1,000 volt amps and a dishwasher at 1,100 volt amps. And of course, write this out however you choose, however it makes it best for you. But for me, I look at everything I'm working with in terms of appliances, and I see, okay, I have a water heater, a dispo, and a dishwasher. I write all those first, and then after writing all those, normally on a test, I just do a line or something like this, and I might even do something like this. So now I know there's going to be these separate sections. I'm going to have 4,200 volt amps. Make sure to write down volt amps. And that's going to be for the water heater. For the disposal, the garbage disposal, which is called dispo, we have 1,000 volt amps. And for the dishwasher, we have 1,100 volt amps. Okay, and we get the answer 6,300 volt amps. And that is our final answer. And this is because we see we're only working with 3 appliances here. Okay, the rule's 4 or more at 75%. If we only have 3, we're not doing a demand factor. So we end up with 6,300 volt amps for the final answer for these 3 appliances. Okay, third question. Again, I'm going to read it first and then write it down. We have a main water heater for a house at 4,200 volt amps. Then we have a secondary additional water heater at 3,500 volt amps. We have a garbage disposal at 1,000 volt amps and a dishwasher at 1,100 volt amps. I think one of the best things to be able to do is read these questions and kind of filter out the BS. So when it says, oh, you have a main water heater and a secondary water heater and all that stuff, I'm just going to think that I have 2 water heaters. I have water heater 1 and I have water heater 2. Obviously, water heater 1 will be the main water heater. I don't really have to think about it much. Next, I know I have a garbage disposal. Of course, I'm just going to write dispo. And then I have my dishwasher, so I'm just going to write that all with no vowels. Okay, I'm going to draw my line like I'd probably do. And if I was on a test, I'd look at this right off the bat, and I would take note that I'm looking at 4 appliances here, and I would write that down right away. Okay, so I already know I have 4. 1, 2, 3, 4. So I already know I'm going to have that 75% demand factor. Now it's already going through my brain just by analyzing this. Now I'm going to continue to write down the numbers from the question. I have 4,200 volt amps for the first water heater. I have 3,500 volt amps for the second water heater. Do not forget to write down volt amps, even if you think you're confident and it's a no-brainer. It's going to do you a lot of good if you can look back at it and see things labeled. Okay, so we have 1,000 volt amps for the garbage disposal, and we have another 1,100 volt amps for the dishwasher. We're going to add these all together. It's pretty simple. I'm always going to use a calculator. And we get the number 9,800. We already know that we have 4 appliances, so we're going to have that 75% demand factor. In other words, we're going to multiply by 0.75. 9,800 times 0.75 is going to give us the number 7,350 volt amps as our final answer for these 4 appliances with the 75% demand factor. So you can see it's all pretty simple. Each one of these separate categories in the load calculation is pretty simple, and you just got to learn each one and then add them all together. Of course, how this is normally taught is all at once. Okay, so just know you can break it up and you can look at the separate sections like we're doing here with these questions. And then at the end of this, we're going to add this all together into one big question that's going to add all this stuff together. Make sure to highlight the stuff mentioned in the code book. So if you forget, you can go back and it's there highlighted. Okay, next we're going to be looking at dryers. We're going to look at Article 220.54 and Table 220.54. First, we'll look at the Article 220.54, electric clothes dryers in dwelling units. We see that the load for a household electric clothes dryer should either be 5,000 volt amperes, or it has to be the nameplate rating, whichever one is larger. You could also think about that as dryers need a 5,000 volt amp minimum. Okay, because if it's anything under 5,000 volt amps, you need 5,000 volt amps at least. Or if the nameplate rating is over 5,000, then you're going to pick the bigger one. Okay, so it's good just to think your 5,000 minimum. Next, we're going to get into Table 220.54, and we'll see that 220.54 is actually what's going to tell us our demand factor. Okay, we see Table 220.54 is pretty simple. We have 2 different columns. On the left side, we see number of dryers. How many dryers do we have? On the right-hand side, we have the demand factor. That tells us when we know how many dryers we have, what demand factor are we going to apply to it. Take note of the nature of the demand factor every time. Here we see a demand factor starting at 100%, and as we have more dryers, the demand factor becomes a smaller number. Okay, so we can comprehend this pretty simply that if we have more dryers, then our percent number is going to get smaller, so that's going to equal our total number at the end. Our total number at the end is going to continuously get smaller based on how many dryers we have. Okay, with all that, we're going to look at the first example. So let's say they're asking, what is the total kilovolt amp load for one dryer at 4,500 volt amps? Well, we just learned that we need a 5,000 volt amp minimum, and then we pick the larger one. Okay, so obviously our 5,000 minimum is bigger than 4,500. So that's the number we're going to work with, but now we need to check demand factors. For this, we need to go into Table 220.54, and we need to look under number of dryers, and we see if we have 1 dryer up to 4 dryers, it is 100% demand factor. In other words, we're going to rate this at 100%. We're not going to multiply this by 1. It'd be kind of ridiculous. So we know our final answer is 5,000 volt amps, and it's good to write a little note that we have no demand factor for this and that it is at 100%. Something like that, no demand factor at 100% to this. Now we simply have it labeled and we have an answer. When we get further into the load calculations where we have many different things, it's going to be good to do stuff like this, because then you're going to see this number that we came up with, and then you're going to say, I think this is my total number, and then you're going to know for sure, oh yeah, there's no demand factor, it's at 100%. I already solved this completely. It'll just help you out. Next question, we want to know the total kilovolt amp load for one dryer at 5,200 volt amps. So we know we want that 5,000 minimum. We see we're already working at something that's bigger than the minimum. Okay, so we're actually going to be working with the nameplate rating is what that's called. That is the nameplate rating. Here's what they're giving us. As you'd get this from the nameplating of a motor, I'll show you what a nameplate looks like here, and this is something you're commonly going to see on the site, just so you're familiar where this number comes from, what you're working with, what the nameplate actually is. Okay, so the 5,000 is that minimum number, but the nameplate rating is here, what they're giving us. Okay, so now we have the 5,200. We need to look at demand factors. Again, we're looking at table 220.54. We see one dryer is rated at 100%. Again, we already know that, but just to kind of solidify the simple process of looking at that section of the table, now we see we're dealing with 5,200, and make sure you label it volt amps, and that is going to be at 100%. That's normally just how I label it, and I put that next to the answer it correlates with. So at 5,200 volt amps at 100%, okay, I know I figured out my answer, and I can see it, and I see that my demand factor is already figured out as well. Now, if we want to simply convert this into kilovolt amps, which they might have on the test questions, kilovolt amps. So now all of a sudden they might say that you have 5.2 kilovolt amps. Okay, the best way to think about a kilovolt is there's 1,000 volts in a kilovolt. Okay, so kilo means 1,000 volts. So when you think of the number 1,000, of course you have 1 with a comma and 0, 0. So whatever number you think, just think that the comma is replaced with a decimal point. So if you have 1,000, now you have 1. Okay, but same thing if you have something less. If you have 500, okay, you can imagine that your comma would come before that. Okay, and now it's going to become 0.5 kilovolt amps. Okay, you see what I'm saying? So just think of the comma and the decimal point in place of each other. That's the simplest way to think about kilovolt amps, because a lot of times in math you could think about all the complexities and really understand what's going on, but when you actually just solve for things and actually write down the questions, solve the answer, and you do that multiple times, we know this is how we were taught math in math class. This is because this method for teaching math works. You just do the thing over and over and over, and your brain just knows, okay, you take these two numbers and you do this to get this. It actually works better to do that when you're dealing with math than try to sit here and really understand that, okay, well, we're dealing with 1,000, so we got to do this, and we could use this certain formula to get whatever. Just think of a simple way that you can comprehend this to make it simple for you. Okay, next question. What is the total kilovolt amp load for a duplex with one dryer in each unit with a nameplate rating of 4,800 volt amps per unit? Okay, so we're working with the duplex. We know that's the terminology for a two-family home. We see that it's 4,800 volt amps per unit, but we do know that we have a 5,000 minimum per dryer. Okay, and since we're working with each dryer there, we know we have a 5,000 minimum. Not only that, but we have 2 units. Okay, so we have 5,000 minimum times 2. We simply get 10,000, and of course 10,000 volt amps, and we're looking for kilovolt amps. The next thing to do is look at table 220.54 for demand factors. By now we already know that 1 through 4 dryers is at 100%, but it's good just to double check. Okay, so we know it's at 100%, and now we're looking for kilovolt amps, so we're just going to convert it. Like I was saying, we're going to turn that comma into a decimal point. So if we do that, we'll see we'll just have 10 kilovolt amps as the answer. And of course, the turning the comma into decimal point is working in that 1,000 place there. Okay, of course it won't work above that. But doing that is kind of more of just understanding what a kilovolt is than anything else. You can just glance at 10,000, you can say, okay, it's 10 kilovolt amps. You can glance at 5,000 and say, okay, that's 5 kilovolt amps. That's basically the process. You should just be able to glance at it. Okay, next one. We want to find the total kilovolt amp load for an 11 apartment multifamily dwelling with 1 dryer per unit at 5,000 volt amps each. Okay, so we know we need the 5,000 minimum, and we have 5,000 as our nameplate rating. Okay, so we're going to take the 5,000, and we see we have 11 apartments. So first thing we're going to do is we're going to multiply by the 11 apartments. In any scenario, we're going to multiply by the number of units that we're working with. So we have 55 85,000 as our number there. Okay, but now we need to check for demand factors. When you're doing all of your load calculations, your book is basically open to the same 3 to 4 pages anyway, so why not just double check real quick? Your book is probably already open to this page. And of course, we're looking for this one. But I mean, for any other circumstance where you think you already know the answer, you're already looking here, why not just take a look? Okay, so we're looking at 11 apartments though. Again, we're looking at table 220.54, and we see the number 11, and we see 47 as a demand factor, which is a percentage. It tells us all of this in the table. Okay, so now we know we want 55,000 times 47%. So I'll do times 0.47. Okay, and we get the number 25,850, of course, volt amps. Okay, and that's what I meant by the demand factor decreases, okay? So as we see, now that we had 11 apartments, we had a 47% demand factor, and that meant that our total answer is 47% of what it was originally. So when we end up with a number of 25,850, which seems like quite a large difference, and we know that we started with 55,000, well, we can glance at that, we can see 0.47 around 50%, and we can say, okay, well, that makes perfect sense by looking at that. That's why it's good to comprehend this, because if you glanced at this and all of a sudden something seemed a little bit off, you could double check and see maybe you accidentally plugged something in wrong in your calculator, wrote something down wrong, or who knows what. Okay, but we're looking for kilovolt amps here. So all we're going to do is convert this to kilovolt amps. So we're going to have 25.85 kilovolt amps. Okay, and you see we're going to the 100th place here with our decimal, the 10th, 100th, and 1000th place. So if we get into the 1000th place of our decimal, which as you can see if we turned our 25,000 into a decimal would be the 0. Okay, so we use this 0 to round down to the 100th place. If the 0 happened to be a 5, let's say, then all of a sudden we turn this 5 into a 6. We'd actually end up rounding up. Okay, and that's when we're doing our kilovolt amps. Well, I'll probably see an actual example of this when we get to it, but just so you know, you're only going to the 100th place there. Okay, next question. We want to find the total kilovolt amp load for a 17 apartment multifamily dwelling with 1 dryer per unit at 5,000 volt amp for the nameplate rating. Okay, so we see we simply have 5,000. We know that's our minimum. That's per unit, so we know we're working with 5,000. We also know we have 17 apartments. 5,000 times 17 is 85,000. Okay, so now that we know that number, we need to look for demand factors in table 220.54. There we can see after 11 dryers, it gets into something a little interesting. Okay, and we're going to see that if we have 12 through 23 dryers, we're going to be working with 47% minus 1% for each dryer that exceeds 11. Okay, we see 11 was at 47. And we see we're going to be minus 1% for each dryer exceeding 11. So we're just subtracting one number. Simple way to think about this would be that we started with 17 apartments. Okay, we know that up to the first 11 is going to be rated at that 47%. Okay, so we're going to subtract 11 from 17, and we're going to have 6 left over. Okay, so we're going to know that we have our 11 at 47, but we're going to have 47 minus 1% for every additional dryer past 11. Okay, so we're just going to do 47 minus 6. We're going to end up with 41%. Okay, you see the number keeps decreasing, and that's going to tell us our multiplying number that is going to give us our final answer. And because the percentage keeps decreasing, we're going to end up with a smaller and smaller and smaller number. Okay, so now we're going to take our 85,000 that we're working with, okay, and we're going to multiply that by 41% or 0.41. We're going to come up with the answer 34,850, of course, volt amps here. That will be our final answer with the demand factor, okay? And for the label is the math above it, okay? So you see 85,000 times 0.41 we already see that we got our 41%. We worked at that. We could glance at this now and we could see how we got our final answer. And we could see we're also working with 0.41%. And we could see, okay, that looks about accurate there. Of course, the question did ask for kilovolt amps. So if we actually were looking for that, we could just turn this into 34.85 kilovolt amps. Okay, so now we're going to be looking at ranges, and we're going to be looking at article and table 220.55. We see article 220.55 mentions ranges rated in excess of 1 3/4 kilowatts shall be calculated with table 220.55. So we know we're going to be using table 220.55. And now let's take a look at table 220.55. We see it as demand factors and loads for household electric ranges. Okay, so it's not only just demand factors, but some of these are the actual loads that they're going to be telling us. So we see on the first column, on the left-hand side, we're looking vertical right now. It says number of appliances. Okay, when we see it goes down a list of several different numbers. Then we see column A, less than 3.5 kilowatt rating. Okay, so in other terms, this is saying if we have anything 3.49 kilowatts and below, we're going to be using column A. Then we look at column B, and we see that is 3.5 kilowatts through 8 3/4 kilowatt rating. So that explains itself. We have 3.5 through 8.75 kilowatt, and that is our range that we're going to be working with if we want to be using column B. We see both of these above it says demand factor percentage, okay? So what that's telling us is that when we're using the left-hand side, the number of appliances, and we're using either column A or B, we're using a demand factor percentage, okay? So highlight percentage with one color. Let's say you highlight percentage yellow, okay? And then highlight column A, that same color, column B, that same color, and all of the numbers for that column vertically, just do a line that same color. That way you can glance at this, and without thinking about it, your brain is going to see the percentage, column A, column B, and all those numbers in yellow, and it's just going to associate it really quickly. You're not really going to have to think about it. You are going to get used to this table, but I find that a really good way of labeling it. Okay, that takes us to column C. We see the maximum demand in kilowatts. Okay, and this is not over 12 kilowatt rating. Now for this, I recommend highlighting kW kilowatt in both locations next to where it says maximum demand kilowatt, and it says not over 12 kilowatt. I would highlight both those a different color than you did for your percentage. Okay, you want to differentiate these two. If you did the percentage in yellow, maybe you're going to do this in orange. Okay, so you're going to do kilowatt in orange, and then vertically highlight all those numbers in orange, 8 through, at least 40. You're going to know under that it's going to fit with them, but I would just recommend doing that. We're highlighting this a different color because above this, you see it doesn't say demand factor percentage. When we're reading this, we see the maximum demand in kilowatts. So this is actually just telling us a load. It's not telling us a demand factor. And it's in kilowatts. So it tells us 8, that's 8 kilowatts. Okay, below the 8 we see 11. That's not 11 watts, that's 11 kilowatts. Okay, in other words, 11,000 watts. Okay, and this is simply all we're going to have to know to figure out calculations for our ranges. We do see the demand factors in table 220.55, and we do see in column C, if you keep going down, it goes 15 kilowatts plus 1 kilowatt for each range. Okay, so we're going to get into how we're going to figure this out. We will have a question that will involve this. Okay, next question. We want to know the total kilovolt amp load for 3 3-kilowatt ranges in a dwelling unit. Okay, so how are we going to approach this? This one's a little interesting. First off, the actual rating of our ranges is 3 kilowatts. So we're going to go into table 220.55, and we're going to look for our 3 kilowatt. We see that column A is less than 3.5 kilowatts, so we're going to use column A. Okay, so I'm going to write that down. We're going to be using column A with our 3 kilowatts, and I have 3 of them. So it's column A at 3, and I'm just going to put appliances. And we see that if we look at column A, under 3 appliances, we see a 70% demand factor. Okay, so I'm going to say that equals a 70% df for demand factor. I'm going to circle that because that's a crucial part that I need for my answer. And now, was 70% is my demand factor of what? Well, it's my demand factor of these ranges. Now I have 3 of them that are 3 kilowatts. So I can simply just get the total of that. And I get 3 ranges by my 3 kilowatt. And I'll get 9 kilowatts. Okay. And then I'm just going to have to get my 9 kilowatts and get 70%. In other words, times 0.7. And when you're working with kilowatts, instead of converting into thousand and converting it back, you can just keep it where it's at. Because you can get 9, and you can multiply it by 0.7, and you'll get 6.3. But now you know your answer is 6.3 kilowatts. And that is the final answer for these 3 ranges at 3 kilowatts. Of course, that would be 6,300 watts. Okay, next one, we're looking for the total kilovolt amp load for 2 3.2 kilowatt cooking appliances in a dwelling unit. Okay, so cooking appliance range, we're going to be doing the same thing. First off, we'll look at the rating, 3.2 kilowatts. We'll go into table 220.55. We'll see column A, which is less than 3.5 kilowatts. Okay, I'm going to take a note that we're working with column A. After this, I'm going to also take note that we have 2 appliances. Okay, so with column A at 2 appliances, going back to the table, and we see 2 appliances, column A is a 75% demand factor. Okay, so I'm going to write 75% DF. And now next, I'm going to get to my rating, which is 3.2. I'm going to multiply it by how many actual ranges that I have. I'm going to get a total number of 6.4, and remember, these are kilowatts. That's why it's good to always label this, because if you forgot this was kilowatts, so that'd be a very important thing to remember, because this doesn't mean 6.4 watts, it means 6,400, okay? We know it's 6.4 kilowatts, and 6.4 times 0.75 gives us 4.8 kilowatts, okay? And that is the final answer for this question. Okay, and that is the final answer for this question. Okay, next question. What is the total kilovolt amp load for a 7 kilovolt amp range in a dwelling? Okay, we have 7 kilovolt amps as our rating. We go to table 220.55. Okay, we see a 7 kilovolt amp rating. We go to the table. We see column B is 3.5 kilowatts through 8.75 kilowatts. So obviously we're working with column B here. So I'm going to write that down. So I'm going to write all that down. I'm working with column B. Not only that, but I am working 1 appliance. So column B at 1 appliance equals, and we see an 80% demand factor there under column B. Okay, now we know we get our 7 kilovolt amp rating that we started with, and all that we have to do is apply an 80% demand factor to it, and that's going to give us our answer. Times 0.8 is going to equal 5.6. So now we're going to have 5.6 kilowatts as our load for this 7 kilovolt amp range. Okay, next question. We want to know the total kilovolt amp load for a 14.6 kilovolt amp range in a dwelling. Okay, here we are back in table 220.55, and we see that we're going to be in column C, but we're above a 12 kilowatt rating. Okay, and we see that it says maximum demand, not over 12. Here's where we have to read the informational notes where it says notes, and we're going to read the first one. It says over 12 kilowatts through 27 kilowatts. And for this, it says that the maximum demand that is in column C shall be increased 5% for each additional kilowatt of rating or major fraction. Okay, so really keep in mind it's that major fraction. And we're going to see exactly what this means in a second here. Okay, we're working with 14.6 kilowatts. Okay, we know that's given to us, but the thing is we want to work with each major fraction. What this means is we're going to get this decimal, and instead of it being a decimal, which could be a fraction, we're going to turn that into a whole number of 15. Okay, so we're going to round that up. Of course, if that was below 0.5, we would round it down. And we see the reason why we're raising this is because it says in the informational note we're using each major fraction. Okay, now that we have the 15 kilowatts, we need to label the fact that we're working with column C here, okay? Additionally, we only have one appliance, okay? So remember the rules for 12 through 27, you can look at it again. We're going to use the demand that's in column C, but we're going to increase it by 5% for each additional kilowatt or major fraction. Okay, so what we're looking at here is the demand in column C for one appliance. We see that's the 8 kilowatt load rating. Okay, so now we need to think here. We're working with the demand in column C, and we're going to increase that by 5% for each additional kilowatt. Okay, so where does each additional kilowatt come from? The demand in column C is the answer that we got from knowing one appliance. The only other information that we can gather here is that we have the 14.6 rounded up to 15 kilowatts. Okay, there's nothing else that we're working with. And we can also think about this logically, but just process of elimination here, there's nothing else. Okay, so we're going to have to think about this 15 kilowatts here when we're thinking about increasing by 5% for each additional kilowatt or major fraction. Okay, because now we know the number that we're actually going to be working with. Okay, so we have our number 15. Okay, and we need to think about what we're doing here. We're working with something that's over 12 kilowatts. That's what we see in column C, not over 12 kilowatts. The informational note is telling us 12 kilowatts through 27 kilowatts, okay? So if we read the end of the informational note 1, I'm mentioning this now because it's kind of a lot. It's saying that the increase of 5% for each additional kilowatt is going to be when the range exceeds 12 kilowatts. So we have 15 kilowatts, and we're going to subtract 12 kilowatts, because anytime it goes over 12 kilowatts, we're going to take that excess number, okay? And the excess number is going to tell us how many 5% we're going to add to this. It sounds kind of weird in concept when I say it, but we're going to see this is very simple. Okay, so we have our 3 kilowatts left over because we started with 15 kilowatts here, okay? And we're raising 5% when we go over 12. Okay, so what's left over 12 is 3 kilowatts, okay? And 3 kilowatts are going to each be at a 5% rating, okay? And what does that mean? Is that means that we're going to have 3 5%, okay? So if we're looking at a decimal, we could look at 0.15, because 5 times 3, or 5, 10, 15. Okay, so 0.15, but we don't want to get 15% of what we're working with. We want to have a 15% increase. The simplest way to increase something by a percentage is to get the decimal that you want to increase by that percentage. I want to have a 15% increase. Okay? And I'm going to think simply, if I get the number 2 and I multiply it by 1, I'm still going to have the number 2. So we're working with this whole number here, 1, that's always going to give us the same number we're working with. Let's say I have 2 and I want it to be increased by 15%. Okay, so what I'm going to do is I'm going to take that number 1, and that's going to give me still the number 2, but I want an additional 15% added to that ending number. So I'm simply just going to do 2 times 1, 0.15. We don't need to worry about the answer. What we need to know is that what we're going to be working with here now is 1.15. That is what we're going to use to multiply the 8 kilowatts. Okay, so let's think about this. We have our 8 kilowatts, which is the rating from column C at one appliance. That's the 8 kilowatts. Then we have the additional 5% per each kilowatt that goes over 12 kilowatts from what we had in the beginning. Okay, so we had 15 in the beginning, so we have 3 at 5%. So let's think about what we're doing. We have the 8 kilowatts, which is simply when we went into column C with one appliance, since our rating took us into column C, we got 8 kilowatts. Okay, since we have 3 at 5%, we have the additional 15%, and just like I showed you, we're going to get the 1.15, that's what we're going to multiply this by, and 8 kilowatts, remember, times 1.15 is going to give us 9.2 kilowatts. And that's going to be the final answer for this question. Okay, next question, we want to know the total kilovolt amp load for one 3-volt amp cooktop and 2 4-volt amp wall-mounted ovens. Okay, so we see we're getting some different terminology in here, talking all about ranges here. We're going to be using the table 220.55 still, and we need to comprehend the fact that we have 2 different ratings for 2 different styles of ranges. Even if they were the same style, we have 2 different ratings, okay? And because of this, we're going to separate these, and then we're going to get our demand factor separately for each rating, because they're going to have their own separate demand factor. Then after getting that number with the demand factor, we're going to add our numbers from each of the 2 different types of rated appliances, and we're going to get our final answer. This is going to explain itself. Okay, just remember to separate it. So I'm going to write this down, 3 kilovolt amps, and below it right here, I'm going to write down the 4 kilovolt amps. Okay, now I want to find the demand factor for each one of these ratings of ranges. So I'm going to go back into the table. I'm first going to look for my 3 kilovolt amps. I'm going to know that's column A, less than 3.5. I'm going to see one appliance is 80% demand factor. So I'm going to write that down. I'm going to write down column A at 1 appliance is going to equal my 80%. Okay, it might seem a little ridiculous to write all of this, but this is really going to help us remember this. And if you don't end up writing all this on your test, you probably won't. This will be in your head, and you've written it out the long way so many times that it's really going to help you out because you're going to know what you're doing more. It basically is just little things helping you keep track along the way. Okay, so next we want to look at the 4 kilovolt amps. For this, we know we're above 3.5, and we're in column B here, and we need to keep in mind that we have 2 appliances. Okay, I should have wrote this, but you don't have that in mind. You can always write that right now. I have my 2 4 kilovolt amp appliances, so I'm going to have column B 2 65% demand factor. Okay, now I'm going to write down that my column B at 2 appliances is my 65% demand factor. Not only have I written down how I got these answers, I can double check if I think, did I actually do this correctly? And I can look back at everything and I can quickly see, okay, yes, everything looks correct to me. Now we can do the math. We have 3 kilovolt amps. We only have one of those at 80%. Okay, so we have a simple 3 kilovolt amps. So I'm going to label it just so I remember that it's actually kilovolt amps. And I'm going to multiply that by my 0.8. And now before pulling out my calculator, being in the same train of thought, I have 2 4 kilovolt amp appliances. I could write 2 times 4 out for you, but I think we know what that is. Okay, so we have 8 kilovolt amps, and that's going to have the demand factor of the 65%. So we're going to multiply that by 0.65. Okay, now I'm going to just pull out my calculator and do both these real quick. 3 times 0.8 is going to give me 2.4 kilovolt amps. And then 8 times 0.65 is going to give me 5.2 kilovolt amps. Okay, now we're going to add those 2 together since we solved for them separately with our demand factors. And we're going to get a total of 7.6 kilovolt amps as our load for these appliances here. And now we're getting into heat and AC, what some people call HVAC. I personally like to separate it as heating and AC. It goes along with the way that I was taught, the way that I'm going to teach it. But you might have your reasons for labeling it as HVAC. But whatever it is, you have either one that you can use. We're going to be looking at Article 220.60, where we're going to see non-coincidental loads. And they just call it non-coincident loads. And what it says is that where it's unlikely that 2 or more non-coincidental loads are going to be used simultaneously, it's going to be permissible to only use that largest load, okay? But now what's important is what this applies to, okay? Because in load calculation, we're going to have heat, we're going to have AC. Part of the reason why I like separating these is because what this non-coincidental load applies to is heat and AC. We assume that people living in the house are not going to be using their heater and their AC at the same time. Although people often do, we assume that they're probably not going to out of being logical. Because of this, we're simply going to pick the larger one out of the 2. So if, let's say, we had a 5 kilowatt AC and an 8 kilowatt heat, then we'd pick the heat and we would not pick the AC. So in our load calculation, if we're doing a whole house and we had the heat and the AC, and we ended up picking the heat because it was the bigger load, then we're only going to count the heat. This only has to do with heat and AC. So that's why it's going over heat and AC as non-coincidental loads, because you basically only do this for heat and AC where you're picking the bigger one of the two of these two different things, heat and AC. Okay, and once you've done this a few times, you'll remember it. It's very simple. Okay, first question. How many volt amps when we're looking at one 18 amp air conditioner, one 1.8 amp blower, and one 10 kilowatt heat strip, all at 240 volts? Okay, first we want to find out the numbers that we don't know. We have 18 amps and 1.8 amps, both at 240 volts. Is 18 times 240 as well as 1.8 times 240. Okay, so now we need to know when it's saying a 1.8 amp blower, that's going to not only be a part of the AC, but also of the heat strip. Okay, so because of this, we can see if we get our 4,320, the volt amps of the AC, and we add it to the blower volt amps, we get 4,752. But if we look at the 10 kilowatt heat strip, which is 10,000 watts, and we add the 432 watts to that, we get 10,432. So we know we were already going to pick the 10 kilowatt heat strip to begin with. It's obviously bigger, but if we wanted to add this number that's bigger to our load calculation, we need to add the correct number. And if we just add 10 kilowatts, we're not going to get the correct number. We still need to add the additional wattage from the blower. Okay, and there we are with the final answer, 10,432 watts, or converted into kilowatts, 10.43 kilowatts. Okay, next we're looking at how many volt amps when we have one 28.2 amp AC, one 3.2 amp blower, and one 6 kilowatt heat strip, all at 240 volts. Okay, we're going to get both of the numbers that are just in amps right now. We're going to convert it into watts by multiplying it by the volts. We have 28.2 times 240, which equals 6,768. Should probably actually put an equal sign for this. And then 3.2 times 240, 768. When I add those two together, I'm going to get 7,536. Okay, and if we look at the 6 kilowatt heat strip, we can simply do this in our head. We have 6,000 watts, okay? And then if we have the blower, the additional 768 added to that, that's just 6,768. We can see that plain and simply. And in fact, the AC with the blower is going to be bigger than that. Okay, so we're going to pick the AC with the blower at the 7,536 volt amps for the final answer. Okay, but actually here's a perfect example if we want to turn this into volt amps and how we're going to round this. Okay, so of course we're going to get 7.5, but then we see the 3.6. Okay, so like I was saying, we're going to go into the 100th place, but then we see next to it is a 6, so it's going to tell us to round up. So if we want kilowatts, then we're going to have 7.54 kilowatts as our final answer. Okay, now we're getting into the lighting load with the demand factor. We're going to be looking at table 220.42, and we're going to be keeping in mind that dwelling units are at 3 volt amps per square foot, plus the 4,500 volt amp minimum that we are going to add for the 2 small appliance branch circuits and the laundry circuit. When we look at the table, we see that the first 3,000 volt amps are at 100%. This will make a lot more sense when we actually solve some problems here. Okay, next we see from 3,001 to 120,000 is at 35%. You see, I'm labeling this as a range of 117,000. The reason is because if you take the 120,000 that we're able to go to in this section, and you subtract it with the section we're taking away from the first section of 3,000 volt amps, 117,000 is the amount that we can have in this second section here, 3,001 to 120,000. That's why it's sometimes good just to think 117,000, which you can think quickly when seeing 120,000 subtracted by 3,000. Okay, and now the third section, we have the remainder over 120,000. Anything over 120,000 is going to be rated at 25%. We're going to get each of these sections separately, and then we're going to add them all up. Okay, and this is going to be very confusing if I try to explain this without actually doing it. So let's get into some examples. Okay, next we want to know the total volt amp lighting load for a 1600 square foot home. This will include the additional 4,500 volt amps for the 2 small appliance branch circuits and the 1 laundry circuit, as well as the demand factors we just talked about. Okay, and this is going to show us how we put everything together, how we use these demand factors, and this is going to make sense because of what we read in the code book before all this. Okay, so we have a 1600 square foot home, so we know we're going to take our square footage of the home and we're going to be dealing with 3 volt amps per square foot. In other words, we're going to take our square footage of the house, we're going to times it by 3. 1600 times 3 equals 4,800, and of course that's going to be the volt amps. Okay, so now we have the number that we could call the square foot volt amps. Okay, the volt amps that correlate with the square footage that we have. Then we're going to take that additional 2 small appliance branch circuit plus laundry, and we're going to have the additional 4,500. We're going to add these two together. 4,800 plus 4,500 gives us 9,300. Okay, now we have the volt amps that we are working with when we combined the actual square foot volt amps with the mandatory volt amps, the 4,500. We know where that comes from by now. Now we're going to be dealing with those demand factors. Okay, so we know that the first 3,000 is going to be at 100%. Okay, so in other words, we need to get rid of 3,000. And how some people say is we get rid of it, then we add it back. We need to get rid of 3,000 because we need to know what this number is after 3,000. We're going to count 3,000 at 100%. So I guess we'll say we'll put it aside for now. Okay, and what we're going to do is we're actually going to label it 3,000 at 100%. Okay, and I am going to circle this over here. I actually didn't need to circle that, so I'm actually going to uncircle that. That's unnecessary right now. Okay, what I like to do sometimes when I'm dealing with a number, I don't want to circle it yet, is to do a dotted circle. Okay, so my 9,300, I took away 3,000 because I want to rate that at 100%. We see I have 3,000 at 100%. I already took care of that, okay? And now because I subtracted that, what we're going to have left over is 6,300. What I said about the next section is we can have 117,000. We're obviously way under that, so this fits in that next section. It doesn't go any over into the third section, which is anything over 120,000, which here would be anything over 117,000, since we already are rating 3,000 at 100%. So it's a lot to kind of take in the first time here, but after doing it a few times, it really is pretty simple. What we really need to comprehend is that since we took away that 3,000, what we're left with is that number in that second category range, which we remember everything in there is multiplied by 35%. Okay, so we're going to multiply it by 0.35. We're going to get 6,300 times 0.35, and we're going to get 2,205. Okay, now I'm going to circle that as well, so now we know we have our 2 numbers we're working with. I'm going to get the 3,000, and I'm going to add the 2,205, and I'm going to get 5,205. Okay, and again, if we want to take 5,205 and turn it into the kilovolt amps, we could turn this into 5.21 kilowatts. I'll just call it kilowatts, because we see that the 5 is before this 100th place here. It's telling us to raise that 0 to a 1. Okay, next we want to find the total volt amp lighting load for a 1,200 square foot home. Okay, first we're going to find that square foot volt amps, and to do that we're going to get our square footage, our 1,200, and we're going to multiply that by our 3 volt amps per square foot. That is going to give us 3,600 volt amps to start off with, and we know this correlates with our square footage. Then we're going to add the additional 4,500 for the 2 small appliance branch circuits, and one laundry circuit. We're going to add these together. 3,600 plus 4,500 gives us 8,100. Again, label everything. These are volt amps we're working with. Okay, and now we have the demand factors. Okay, remember the first 3,000 is going to be at 100%. Therefore, again, we're going to get rid of 3,000. Basically like we're putting it aside because we want to find out the number without 3,000. Okay, we're going to label that we now have 3,000 at 100%. I'm going to circle the 3,000, and I see labeled next to it that this is at 100%, so I know this is all taken care of already. I also have a memory of it, and doing this solidifies that memory even more. Okay, moving on. Now 8,100 minus 3,000 is 5,100. This is what I have left after taking out my 3,000. Okay, now I'm in the second section where I can be up to 117,000 volt amps. I know that is going to be 35%, so I'm going to multiply this by 0.35. 5,100 times 0.35 is going to give me 1,785. And I'm going to add 3,000 and 1,785. We can probably do that in our head there. And we're going to have 4,785 volt amps for that final answer. Okay, and again, if we want to turn this into kilovolt amps, we'll simply just get 4.79 because the 8 is rounded up with the 5 next to it. Okay, now we're going to get into the whole house load calculation. We're first going to look at the page setup. How are you going to set up your page when you're solving for whole house load calculation? This is very important so you don't forget anything, miss any steps, or leave anything out. Okay, so if you followed all the steps in this video, you know that we're going to need to know our general lighting load. Okay, I'm just going to abbreviate that as Gen Light. Okay, we know how to solve for that now. We also know that we need to know our fixed appliances. Okay, that was completely separate. We're probably just going to end up calling this appliances, but for now I'll call this fixed appliances while we're still a little fresh with this. Next, I'm going to give you something, and this is a very good thing to know. Just remember hard. Okay, and that is hard. H-A-R-D. You see I put the H-A a little closer, and then a space with the R, a space with the D. You'll see why I do this in a second. The H stands for heat. The A stands for AC. The R stands for range. And the D stands for dryer. Okay, now we know everything we need for a whole house load calculation in a dwelling unit residential, and we're not going to leave anything out. Let's go over it one more time. We need to know our general lighting load. Okay, we need to know our fixed appliance. Other than that, we just need to know hard. H-A-R-D. This is why I like to separate heating and AC, not think about it as HVAC, because here I see heating and AC, and I know after doing this one time that you're going to pick the bigger of heating and AC, but after doing this multiple times, you're not going to forget that. Okay, so we obviously know we picked the bigger one. I also grouped these together kind of close, and then I put a space between range and a space between dryer to further signify and emphasize that. Okay, so that's the basic page setup. Okay, now we're going to get into the actual whole house load calculation question. There's a lot more to it than this. I'm going to read it off. Okay, we're going to want to know the total volt amp demand for a 1,600 square foot home with the following. We have a 11,000 watt range, a 4,800 watt dryer, a 900 volt amp disposal, a 1,100 volt amp dishwasher, a 3,500 watt water heater, a 10 kilowatt heater, and an AC system with 18 amps at 240 volts. Find the total volt amp demand. Okay, so I purposely said some stuff out of order there, so you kind of got to take everything there. If you wrote it down already, or if you didn't, you're going to see me write it down in a second. But you're going to take everything that is all mumble-jumbled, and you need to organize it properly so you do not miss any steps. And remember, with the page layout that I showed you, it's a sure bulletproof way of not missing anything if you actually set it up correctly. Probably got to do a few of these to come up with an actual sure method. Okay, so let's get into it. We're just going to be writing down everything that I read. So I already have the square foot of the home written down. That's going to be the first step. So we'll actually write a little placeholder for that. I'll write a 1600 right here. I'll leave a little space underneath that, and then I'll get into my appliances. And these are going to be the fixed appliances. Okay, so I had a garbage disposal. I just call it dispo. Okay, and then I have a dishwasher and a water heater. Okay, so 3 fixed appliances I'm going to be working with here. It's good to note that. So I'll put a little 3 here next to it just so I know. And I had 900 volt amps for the dispo. I had 1100 volt amps here for the dishwasher. And I had 3500 volt amps for the water heater. Okay, so other than the lighting based on the square footage and the fixed appliances, we have HARD. Hard. So again, I'm going to write down the HA close and then a space between the R and the D. To do this quicker, on the tests you might not actually fill in everything here. That's heat, AC, range, dryer. For the purpose of this video, I'm going to fill it all in. Okay, so now we know what we're working with there. We were told that we had a 10 kilowatt heat. We're told we had an 18 amp at 240 volt AC system, which using Ohm's law gives us 4,320 volt amps. We were told we had a range of 11,000 watts and that we had a dryer of 4,800 watts. Okay, now let's just double check we have everything written down. We have the general lighting, which is going to be the square foot of the home. Okay. We have the fixed appliances. And then after that, we have HARD. It looks like everything is written down, and we already have the number conversion from the amp and voltage to volt amps. So now we can basically get into solving. Let's start from the top down so we don't forget anything. Do one step at a time. We're going to start with the square footage of the house, the 1600. We're going to multiply this by 3. This is going to give us 4,800 volt amps. We're going to take this 4,800 and we're going to add our 4,500, which is our minimum that we have to add for our 2 small appliance branch circuits and our laundry circuit. That's going to give us 9,300 volt amps total for that general lighting portion without the demand factors. Of course, we have to do the demand factors, so we're going to subtract 3,000 from this. We're going to put that aside. When we put that aside, we're going to make sure to label that at 100% so we can add that back into it. Again, instead of circling this, I'm going to be circling my answers that I'm going to be adding all together. So I'm just going to do a dotted circle for this to do a sort of circle, but to signify that it's different. Okay, it's not ready yet. It's not an actual solid circle. This is just how I do it. Okay, so I have the 3,000 put aside. That's going to give me 6,300 left over. I know that in the second section up to 117,000 here is going to have the 35% demand factor. Now 6,300 times 0.35 is going to give me 2,205. Okay, same thing, I'll just do a dotted circle, but now I need to do 2,205 plus 3,000, and we can solve that really simply. We have 5,205 volt amps, and that is going to be for the general lighting there. Okay, since this one's kind of a mess, maybe I'll even write GL there. Okay, so now this is for general lighting. Okay, next moving down, I just did the lighting, so now I can do the fixed appliances, which is pretty simple because we see everything is already mathed out to volt amps here. We're going to take the 900 plus 1100 plus 3500. Okay, we have 5,500, and now we need to check for the demand factors, which we don't have any because we only have 3 fixed appliances, and the rule is 4 or more fixed appliances as at 75%. If it's less than 4, we don't have any demand factor. So here's our next number for our appliances. Again, I could always label it if I want, so I can actually keep track of this. I have appliances. Now I have my number for appliances and my number for general lighting. Of course, those are both volt amps. Next, we're moving on. We have heat and AC. We know we picked the bigger one of the two. We have 4,320 volt amps for AC, and that is going to be smaller than 10,000 watts, obviously. So we're going to pick the heat. We're going to disregard the AC, and we're only going to add the heat to our number. Okay, so we already have that. We can circle that, and we're going to be adding 10,000 to everything. Next, moving on, we have the range. We're at 11,000 watts. Okay, now remember, we need to go into the table for ranges. We see 220.55, and we have an 11,000 watt range. Okay, so we're going to be here in column C, where it is over 8.75 kilowatts and not over 12 kilowatts. Okay, so again, I always like to label that. We're in column C right now, and in column C, we are at one appliance. Okay, and with column C here, that doesn't give us a demand factor, but that actually gives us a load of 8 kilowatts. Okay, and there's no demand factors further than that because that is the load that they're giving us in the table. So we have 8 kilowatts as our number for our range. I've never actually labeled it before, but this is kind of nice because now I can just look at it and see real quickly which one is which in the little bubble that I created when I circled it. Of course, the heat one is pretty obvious because heat's next to it. Okay, but moving on. Now we have dryer. Remember, we have a 5,000 minimum for dryer on the nameplate. And don't just have this memorized, but every time that you have a dryer question, just flip your code book from being from table 220.55, just flip it the next page over, and you're going to see 220.54. It's right there, and you should have it highlighted that you're going to have either 5,000 watts or the nameplate rating, whichever one is larger. Okay, so don't rely on just memorizing all this because you will probably slip up at some point and just forget to do a simple thing like change this to 5,000, and then you're going to be 200 off of your actual answer at the end. Okay, so we have that 5,000 minimum, but not only that, we have a table for demand factors that we should always just double check. We're already on that page. Okay, so that turns into 5,000 watts. Of course, we're going to pick the bigger one. So we have 5,000 watts, and then we look at our demand factors. Number of dryers, 1 through 4, is at 100%. Okay, so I know I have 5,000, and that is going to be at 100%. I'm just going to circle that, so then I know that that is all done and dealt with. And now we have all of our numbers. Let's just double check. So we needed the lighting, general lighting, we need appliance, then we needed either heat or AC, and we have heat. We needed the range, and we needed the dryer. Everything checks off. Now let's add everything up once, and then we'll get a number, write it down, and then add everything up a second time because of all the numbers here and make sure we get the same number. Okay, so let's start from the first one, just so we can kind of go down in order and it'll be easy in our head. We'll have the 5,205 from the general lighting. After this, we'll go into the appliances with the 5,500. Next, we'll go into the heat, where we have 10K, which is 10,000. Then we have the range, because we didn't do the AC. We crossed it out. It's pretty obvious. Where we have 8K, which is 8,000. Okay. And then we have the 5,000 from the dryer. I have 33,705. Now I'm going to write that down and just really quickly do that again. And I get the same number, so everything looks good. Okay, so that's the end of this video. Let me know how you did in the comments down below. The next video will be on the optional method of the load calculation. After this, I'm going to have a video going over the chapters of the NEC Codebook, just so you can know the NEC Codebook that much more. So make sure you subscribe to see more videos around being an electrician and electrical engineering. Of course, if you have any recommendations for videos, I'd love to hear it and consider it as well. Feel free to personally contact me at this email shown above. And if you could please give this video a thumbs up, it will help more people reach this video and see it and be able to learn from it. And until next time, take care. Goodbye.